Let me introduce Stuart Newton from Telestream. Stuart.
Thanks, Eric. Is the mic's working okay? Everybody can hear me? Yeah. Okay. So I'm Stuart Newton. I'm the VP of Strategy for the IQ Solutions division within Telestream. About a year ago, Telestream acquired IneoQuest. Hopefully many of you have heard of IneoQuest, and we became the IQ business unit within Telestream. So what I want to do today is talk about the value of early warning monitoring systems for the complexity of the video we have today. Dan gave a great introduction there actually to some of the complexities with the cloud streaming. I want to give you a feel for how you do the different types of monitoring and what they can bring you. And then I have some case studies at the end where I can just give you some really good, intricate examples of things that we've found over the last few years so you can understand the complexities, particularly around the use of CDNs. So if we look at how video is delivered today, there's a lot of different ways that video can get to you depending on where you are. And this is quite a good example to explain how things work. So if you look along the top line there, you're typically looking at an IPTV or cable video delivery system where you've got a major service provider that owns their own core network. That's going across the top line there. So if you're watching sports in your home on your set-top box, typically that would be coming via the top line there. If you actually switch to using an iPad in the home or your iPhone in the home to using this, looking at the same channel, it will probably go take the second line down, which is go out via a multi-bit rate transcoding system to produce HLS or DASH as an adaptive bit rate. It may go via an on-premise CDN, a proprietary CDN, or it may go via a third-party CDN, come back into the access network at the edge and then down into your home. As soon as you move out of the home, it may come via the CDN again, but it will probably come over the mobile infrastructure or a Wi-Fi infrastructure, which is the third and fourth lines on there. The point is the video can take many different paths. Even by you taking a few steps, it can actually take a very different path to get to you. There's lots of different bit rates, lots of different protocols being used, but what's happening at the moment is there's lots of different paths, lots of different companies own the different elements in the end-to-end chain, and the silos create blame and finger pointing both within and between companies. Even companies that have divisions owning multiple sectors of that chain can have a lot of arguments internally. There's also a lot of change in the industry, new formats, new protocols, the move to DASH, the move to Ultra HD, and now, of course, the move towards virtualized and cloud-based architectures. So a lot of people move into network functions virtualization-based head-ends or cloud-based head-ends, the use of containers with things like Kubernetes for management, huge amount of complexity that we've never seen before in this industry. So the bottom line is we need to stop the brands getting damaged. We need to make sure people have got a good experience. So what can go wrong? Dan's already covered some of these. But poor quality ingest, transcoders can introduce problems, ABR packages can fail. Lots of ways we've seen packages fail because of issues with the streams coming out of the transcoders. Origin servers can become overloaded and unstable. I'll talk more about that later. Content can be prevented from reaching the edge caches. Edge caches are problems. Client players can malfunction. One of the key things to know is that the actual error may be nowhere near the part of the network that's causing the issue. Okay, so a client can cause an issue back up at the origin server, for example. So there's lots of, actually tracking the issue down involves multiple points in the end-to-end chain, and you need to know what you're looking for. So what's needed? We need to stop the finger pointing and rapidly identify the root cause. We need early warning, especially with a lot of event-based video delivery now, major sports events or concerts, things like that. You need to know quickly. Latest episode of Game of Thrones or whatever your particular episode you're watching, you've got to figure out really quickly what's going wrong, and you actually want to do some testing in advance of that as well. You need to monitor what you do control and what you don't. You need cost-efficient monitoring that can be tuned to the value of the content, because long-tail content doesn't need the same amount of money spending on the monitoring as the really valuable live content or the premium VOD assets. And you now need scalable solutions, flexible business models, and multiple deployment options, which I'll come back to later. So how do we do the monitoring? We do the monitoring in two ways. There's passive monitoring and active monitoring. And the way to understand these is passive monitoring is actually looking what's going on the wire via a mirror port, a span port, an optical tap, some kind of way of actually watching the bits going down the pipe. You will get a lot of information, especially monitoring intra-CDN traffic and publishing traffic, by looking at what's going on the wire. And I'll come back to that in a moment. Active testing is different. Active testing, so passive monitoring doesn't put any load on the system. It's just looking at what's going by. Active testing is very different. You're acting like a synthetic client at different points in the network. You can do that at post-origin, you can do it post-cache, you can do it further out at the edge of the access network as well. And what you're doing is creating a demarcation point. The video is good to hear. The manifest's good, it's coming out, the chunks are coming out in a timely fashion. I'm not getting any HTTP errors. At the origin, it's good. At the caching nodes, it's good. And you can test at multiple city locations, for example, and have a lot of monitoring. The great thing about active monitoring is it can test across a whole mesh of different points, from one city to a caching node in another city. You can do lots of cross-testing as well to be able to see what's going on. So active monitoring does add load to the system, but if you tune the monitoring to the value of the content, you'll find that it works out rather well. So if you've got 2 million people watching sports assets, adding active testing in during that sports asset isn't going to make a lot of difference, okay? But you don't want to be doing permanent testing on long-tail video-on-demand content, for example, where you only want to touch it once a day to make sure it's good, make sure you can get the manifest, make sure you can pull a few chunks. So the whole thing needs to be tuned. So the benefits of passive is, as I say, you're looking on the wire. You can find things with passive monitoring that you would never expect. Quite often we put a passive probe in the network and we find things that we weren't even looking for. The stuff that's been happening for years in some of these deployments that the engineers that architected the system had no idea was even a problem. We'll come back to some of that. You can monitor without adding to the network traffic. We talked about that. Device log files are not reliable. They can give you a lot of information. It can take a lot of time to parse those log files. But passive monitoring will spot that an origin server isn't responding or a caching server isn't responding, whereas the actual log files may not even log the origin server may not even see the request because it was being overloaded. So you won't know that it didn't answer a HTTP request because it was just too overloaded and it couldn't actually log the request in the first place. So by looking on the wire, you see everything that's going on. And you can also monitor traffic that can't be seen by active testing. For example, the publishing point out to the origins. Passive monitoring can look at that and make sure everything's good going out. Active monitoring, there's a whole slew of them here. You can just read through them as I'm talking. But you want to find out before people start calling in or finding out on Twitter. You can use stage events. You can start pulling streams before a major event, during the event, and then you can actually watch the ramp down as well, the effect on the chunks and the loading on the CDNs. Authentication, encryption, geolocking, you can check them all with active testing, okay? Measure startup time, latency issues, you can go from locations to locations. It's very well suited to the public cloud because you can spin probes up in minutes, and then you can start testing to the edge of different CDNs in different geographic locations. The list goes on. If you're not doing active testing for premium value content, you really should be. There is no reason why you shouldn't be doing active testing. You need to know it's available. You need to know it's good. You need to monitor as the load ramps up to see if the chunks are still coming out in a timely fashion post-CDN. You need to know that something's going wrong. And this ties into the move towards cloud and NFV and container-based architectures where you can start introducing self-X networks, self-healing, self-optimizing, self-scaling networks. If you've got that real-time feedback loop and you know right then when an issue is starting to happen, you can do something about it. You can spin up more origins, you can spin up more caches, you can start rerouting some of the network traffic. But if you don't know, you simply can't. So this is what typical end-to-end flow looks like with a little bit more detail. You get your transcode at the head end. You get your segmenter or packager that will produce the HLS or dash streams. They'll publish them out to the origin servers. You may have some kind of load balancer in front of the origin servers. That's this side of the origin servers. You may have mid-tier caches doing extra caching in the middle of the CDN. The edge caches are holding as many chunks as they can for a certain time period determined by configurations, maybe at the origin server. And then you've got the clients requesting the chunks and the manifests and the chunks from the caching nodes. If the edge caches have those, they'll respond. If they don't, they will go back to the load balancer and back to the origin server. And there's all kinds of backwards and forwards issues that can occur with this. Okay? So in terms of the metrics, there are hundreds and hundreds of metrics you can collect from that end-to-end chain. If I just flick back to this diagram again, every arrow on that diagram, by the way, is where we can monitor. So where you actually monitor in real life will depend on your budget, what you control, and what you can get access to. Okay? So sometimes you have to monitor in front of the CDN and behind the CDN because you can't get into the CDN. Right? It's the same with the access networks. But the metrics that you're collecting, there's hundreds of metrics, but typically at a video head end, what you'll be looking for is TR101-290 stats on the transport streams, MDI for packet loss and jitter, audio loudness issues, black screen, freeze frame, MOS level scoring, all the kind of things on the picture quality as well. You check absolutely everything at the video head end. And then as you go further down the chain, you're generally looking for manifest issues, as Dan said, packaging issues, chunks, are they the right size? Are they all being delivered? Are they coming out in a timely fashion? Is the origin server responding to the requests from the caching nodes? Are the caching nodes responding to requests from the clients? And so on and so on. And really, the SVA, the Streaming Video Alliance, have done some superb work looking at some of these metrics. And we're part of the Streaming Video Alliance. The next meeting's on Thursday this week. And we're working with the Streaming Video Alliance to make sure that the metrics that they're defining as key metrics for startup time, latency, things like that, are being rolled into the probes. Okay, you good? So let's get to some real-world examples, and then I'll talk a little bit about automation that's starting to come through in these networks now. So these are mainly focused around active testing or passive monitoring issues. All the video head end, the transcoding, the compression issues, there are lots and lots of things you can monitor there. And we've been doing that for, well, InEquest's been around for 16 years now. So there's pretty much any head end issue that we can see on the compression side or the transport stream side, we can catch. These are issues that were detected either at the publishing point, active testing post CDN, or at the intra CDN post origin in the chain. So the first one, sports package launch, intra CDN monitoring showed all traffic was coming from a single caching node. We put a passive monitoring probe at the intra CDN point. All the traffic's coming from a single caching node. It was a DNS configuration issue on the client side. All the clients were being told to go to a single caching node, and we picked that up because we were doing passive monitoring at the immediately post-origin. Post-edge monitoring showed game console only queuing up one segment at a time. This was an unbelievable blame game between three major names in the industry, all blaming each other. Was it the CDN? Was it the access network? Was it the games console? And it was basically the games console at the time only queuing up one segment. So as you can imagine, there was a lot of buffering issues down on the end client. Nobody knew where it's going wrong. We instrumented all the network, and we figured it out pretty quickly. Intra-CDN monitoring found origin server expires misconfigured, meaning that the caching servers weren't actually caching anything, and they were just overloading the origin servers. So the origin servers were getting hit with everything. It's instant. You can just see this when you look at the probe interfaces. Excessively long response time from the origin servers. We managed to prove that it actually wasn't an issue with the response time from the origins. It was actually a load balancing issue pre-origin. So we managed to put in probes, passive monitoring probes, preload balancer and post-load balancer, and we can identify exactly where the issue was. There was a major blame game going on between the head-end provider and the CDN provider as to where the latency was creeping into the system, and we managed to isolate that. CDN vendor not accurately logging HTTP response failures. The errors that we were monitoring were being logged as good in the CDN logs. So after a lot of proving with metrics and reports, the CDN provider eventually acknowledged that actually there was a misconfiguration on their side and there were errors in the system. So we managed to determine that. Active testing can find stalled manifests. If you're ever watching something and it starts looping, jumping back, 10 or 20 seconds and going again, that's a stalled manifest. We can pick that up straight away. And it goes on. The VeriStream is a metric that we produced, which is very similar to MDI. It's like jitter monitoring for chunks, for live streaming chunks. And VeriStream indicates that there's issues. It can tell you the CDNs aren't delivering the chunks in a timely fashion. It's very easy to determine that you've got a loading issue at a particular CDN location or caching location. If it's all of them, then you can trace it back to the origin, see if there's an issue there. If not, you can identify a particular region where the caching is getting overloaded and the chunks aren't coming out in a timely fashion. Okay. lots of things you can do, lots of things you can find, and quite often we find these issues when we aren't actually looking for those issues in the first place. They just appear when you put a probe in the network. So the last thing I want to talk about is where the industry is going. So we've been involved for the last 2 years in a number of projects for virtualized head ends. If any of you know network functions virtualization, the idea to fully automate and virtualize sections of service provider networks, whether it's telco or mobile. And a lot of people are starting to look at building fully virtualized video head ends. And the advantage of doing this is that you can fully automate the deployment of a head end. We've been working closely with Hewlett-Packard on this at Swisscom. There's an announcement about that in the press. And that is HPE have the ability to specify a channel, grab the encoder images, grab the monitoring images, spin up an entire channel with muxes and everything else, spin up a backup channel, literally in minutes. I mean, their goal was to go from 8 weeks to minutes to spin up an entire new channel from a configuration. And if you haven't seen it, go and look it up. There's press releases on this, and there's demonstrations that HPE can show you as well. But one of the key things that they did here, which we didn't fully appreciate when we started on the project, is that how self-healing networks are going to start coming through. When you can start spinning up probes and spinning up encoders in minutes, you can start using the real-time feedback from the probes to actually create self-healing scenarios. So the probe says there's an issue, it's a major issue with the encoder. You can literally just wipe the encoder from the data center, fail over to the backup channel, wipe an encoder from a data center, spin up a new encoder, just grab the image and spin it back up, get it all working, auto-configure it all, set it all up, and then it becomes your new backup channel. So in the past, this was a very manual activity, but if you think about it and you start looking at using the passive monitoring probes, either in the cloud, as appliances, as virtualized instances, and passive or active test probes, these probes can now create a real-time feedback loop through the use of APIs and traps and everything else that they can do to feed back into these automation systems. So anything using Kubernetes in a container-based management system or using OpenStack in a NFV environment, for example, you can start really doing self-healing, self-scaling type functionality, whether it's spinning up more origin servers because you can see the chunks aren't coming out in a timely fashion, correcting for DNS issues, spinning up new caching nodes, that kind of thing. And this really doesn't cover the complexity that's going on. The industry has moved from the left-hand side, which is appliance-based probes a few years ago, to now having to support, KVM, ESXi with VMware, Docker. They've got to be orchestrated by OpenStack, OpenShift, Kubernetes. The permutations now of putting these systems together is just exploded. There's so many combinations that you can do now. So watch this space. You're going to see a lot more of this. As I say, the move to virtualization and container-based architectures brings in a whole new world of self-X networks, or zero-touch networks, as seems to be the terminology that's come through now. And this is why the abstract for this presentation was that monitoring is really no longer an option now. It's going to be, in the past, you could put monitoring in. You could do without it and just throw bodies at it. But monitoring is really no longer an option moving forward. It has to be the real-time feedback loop for self-healing, self-optimizing, self-scaling networks. So with that, I'll say thank you.